students, today we are going to continue to periodic table and we will end this topic hopefully today. If you want to follow me or from your book, or if you want to revise what you learned today from your book, please open page 175 and 177. Okay, so how we are going to start to this topic? Well, first we will learn about the different groups inside the periodic table. Actually, we learned a lot about when we look at the periodic table, what we see, what are the important things about the elements in the periodic table, and we will try to understand, try to analyze this structure of this table more. We learned that in a periodic table, the elements are organized according to their atomic number. It is starting from 1 and it is going like that accordingly, 1, 2, 3, 4, 5, in accordance with the numerical order. And it is given the chemical symbol and element name and average atomic mass. We learned these. What we didn't learn is what is period and what is group. So the rows on the periodic table are called as periods, like the elements in one group. We will learn about the group. These elements are placed according to their atomic number. When you go from left to right in a periodic table, you will see atomic numbers are going increasing by 1 in each element. Okay, and the properties of the elements are changing in accordance with this period. However, we also have something called as group. In a group, each vertical column is representing a group. Here, for example, here. So they are identified by a group number, which is written on the top of each group. So in elements of the same group will have the same properties almost every time. Okay, only these guys are some exceptions, but for these group or for these group, if you see the same color actually on the elements, you will say that they are holding basically same properties, and they have something called as valence electrons. In the same group, you will see the same amount of valence electrons. Okay, so what does it mean? What is the valence electrons? So each element has a number of electrons. We saw this in the unit related with atom. So each element has certain number of electrons, and these electrons are placed in certain circular paths around the nucleus. So valence electrons are the electrons which is found in the outermost shell of an atom. Okay, and these the number of valence electrons of group 18 or 8A has the same number of valence electrons, which is 8. On the other hand, group 1 will have the same number of valence electrons, which is 1 only. Okay, let me also remind you from here, each vertical column represents a group. Okay, if I'm going down like this, I am just analyzing group 1, for example. Each vertical column represents a group. Okay, and elements in a group are similar because their atoms have the same number of valence electrons. And this is important about chemical bonding. Okay, we are using these valence electrons in chemical bonding. We will learn more related with these in chemical bonding. So what else? Each horizontal law on the periodic table is called as periods. We have 7 periods, you will see. We have 7 periods on the periodic table. Okay, each row is considered as one period. So if I say I am talking about an element on period 2 group 1, I am talking about lithium. If I'm talking about period 7 group 4, or let me choose something more easier, period 4 group 4, I am talking about titanium. You can find an element by using group and period numbers. So what's more, actually one of the most important things related with periodic table, it is showing us the properties of the elements. We have some basic properties. We can define the elements. We have 3 groups, 3 major categories for elements here: metals, non-metals, and metalloids. Okay, metals are the elements that are shiny. Like when you hear the word metal, what do you think, what do you imagine? Shiny materials. They can conduct heat, they can transfer heat. If you touch, for example, a metal stove on an oven, I'm sorry, a metal spoon on a stove, you will feel the heat, you will feel the thermal energy, and they can conduct also electricity. We are using to make them make electrical wires. We are using them to make electrical wires, and they have these type of properties. And all these metals share, basically almost all of them share these common properties. Okay, it is you can see this zigzag line. So elements on the left of the zigzag line, this side, considered as metals, except the hydrogen, which you can see here. It is on the left of the metals, but of the line, but it is not considered as metal. It is considered as non-metal. Okay. So they are poor conductors. They can't conduct electricity or heat. They don't shine. They mostly look dull, and they are not strong. They are brittle, and they can be found in the right side of the zigzag line here. You can see these these purple guys. They are all non-metals. Okay, non-metals. Metalloids are the elements that have some properties of metals and non-metals. They are the border of this line. They share some properties with metals, on the other hand also some properties with non-metals. They are in between. That's why they are called as non-metals. So in every periodic table you will see these type of coloring. Okay, now it is also written here: blue for metals, orange for metalloids, purple for non-metals. Okay, and we have some example for each of them, I guess. No. Okay, so also these chemical symbols are showing us if it is solid, liquid, or gas. For example, all black colored letters are in solid form in nature, and red colored elements are in liquid form in nature, and these white colored letters are in gas form in nature, like hydrogen, helium, nitrogen, oxygen, fluorine, chlorine. They are in, all these noble gases are in gas form, can be found in gas form in nature. Of course they can change states but still in nature they can be found in these states as it is stated in the periodic table. So in all types of periodic tables you will see these different coloring, different indications for states, and different indications for the metals, non-metals, and metalloids. They can change. It can change from table to table, but if you can see a key like that, you can easily understand. Okay, but all the elements of course are same, that in every periodic table that you can find on the web, on the book, because this is a generic table that is used worldwide for all type of chemistry. So but these coloring will also help you to understand which one are the metals, which one the non-metals, and what are the metalloids. Okay, just in case you forgot the group numbers, just remember there are also some indications with coloring. Okay, so it is asking us for, here in your book, it is asking for us to give some examples for metals, non-metals, and metalloids. For example, iron. Can you see the chemical signal of iron? Fe. So iron is a good conductor. It's a metal, and we are using iron actually to conduct electricity and heat a lot. So and when we consider the place of iron on the periodic table, we can see that it is on the left hand side, so it's also metal just by considering their place. Also we see silicon. Okay, silicon has some properties of metals and some properties of non-metals, which is used in solar panels, and it is saying that because of its place, it is just on the borderline of the zigzag, which is a metalloid. Okay, and graphite is brittle substance. It is made up of carbon, and it can break easily. It can be found in the top of your pencil actually, and it is non-metal. Basically we can understand that it is non-metal. Let's try to solve this question. So we need to label the information for the element. Okay, this one at the top should be atomic number. Okay, and you can clearly say that this is a symbol, this is a chemical symbol. Okay, so and this is the name of the element, silver. And here at the bottom we can see the average atomic mass of this element. So when you see an element on the periodic table, you can analyze by considering these easily. So now here is another good question I would like to solve with you. So we need to drag these elements to their places. There it is giving us some different places, and we will try to find their places, but it is not giving us the colors, but it is giving us the atomic numbers, and it is giving us the properties. For example, manganese, it is saying it is shiny, and sodium, again, silvery white. Or krypton, it is saying it's a noble gas, and silicon, it is saying it's a semiconductor. So what we know that metals, all metals should be shiny, and they should be placed on the left hand side of the zigzag. Okay, you can see this zigzag. So on the left hand side we have two places. So how can we put these metals to their places? Actually you should look at the valence electrons in order to understand. You should look at the group numbers, but it may be confusing. That's why I would like you to know the properties of these guys. Shiny and silvery white are the properties of metals. Okay, this will be enough for you. Or again, silicate is a semiconductor, which is not like metals, but it can behave like metals at the same time. So that's why it can be considered as a metalloid. It is in between metals and nonmetals. But noble, if something is a noble gas, this group here, all these elements inside this group are considered as noble gases. And krypton is one of them, and we should place krypton in the last group of this periodic table. So here actually we just finished everything I want to say about periodic table, but if you please go back to your book and revise what we learned. Just check what we learned from your book also. You can find it in Module 8, Unit 3, Lesson 2, pages between 175 and 177 will help you to understand this subject better. So see you in the next session. Thank you for listening.